Okay, hello everybody. Let's get this show on the road for the study guide. Okay, so here, find the equation that models the nth term of the sequence. Now these equations, there are an infinite number of them. What is important is that we know that we have, the first term, second term, third term, fourth term, and we can quickly see that this is a arithmetic sequence as it is plus 2, plus 2, and plus 2. So I know my common difference is 2. And then I have a starting point which will have a sub 1 is equal to 17. So we'll use these two parts to make our equation. So we know that the nth term is going to be equal to a sub k, which is, in this case, our k is 1. So a sub 1 is going to be 17, plus the common difference, which is 2, times n minus k. In our case, k is 1. So that is just one of the many versions. You can also, if you decide, excuse me, if you decide to use the 0th term, so you did minus 2 here and got 15, that is fine also. Then your equation would be 15 plus 2 times n minus 0, since it's the 0th term. But so that's 1. Or if you wanted to use the second term, you could have done that too. A sub n would be 19 plus 2 times n minus 2, because it's the second term. 19 is the second term of the sequence, so that would be our offset. So there is just an infinite number of these. Any of those is fine. Find the 12th term of the sequence. So this is when n equals 12. So we plug that in. A sub 12 is going to be equal to, so a sub 12 is going to be equal to 17 plus 2 times 12 minus 1. And plug that in. So 12 minus 1 is 11, times 2 is 22, plus 17 is 39. So a sub 12 should be 39. And that 39 will happen no matter which one of these equations you use. They are all equivalent. Okay, same thing, but now we have a different sequence. This one is geometric. We are dividing by 1/6 each time. Not divide by, we're multiplying by 1/6. We're dividing by 6, but multiplying by 1/6 each time. So my R value is 1/6. And then I just need to pick the first term. So we'll say, since it's geometric, we'll use G. So the first term, G sub 1, is equal to 24. And we can write our function, G sub n is equal to our first term that we picked, or whatever term we picked, times 1/6 to the, since it's exponential, n minus k, and since I use the first term, our k is 1. There we go. Next up, we have find the 7th term of the sequence. So we want to find G sub 7. So I plug in 7, so it's going to be 24 times 1/6 to the 7 minus 1. Plug that into your calculator. Do I have my calculator handy? It doesn't look like I do. Oh, I have one right here. Great. So we would just plug this in real quick. 24 to the times 1/6 to the 7 minus 1. And we get this ugly number right here, but that's just scientific notation. And we can always hit the math button and convert that to a fraction, which is 1 over 1944. Bam. There we go. Okay. Which of the equations could represent the sequence? Now, this one it didn't say select all that apply, but it's select all that apply. So looking at this one, this is an understood 1 here, and this is a 1 right here. So this is our k. So the first term of our sequence, since this is k is 1, k equals 1, the first term of our sequence should be 1. That's what this one means right here. Here, this one, it should say this is at n minus 0, so this is k is 0. So this say the 0th term of our function should be 1/4. So that should be a point. This one says that this is at n minus 0, so this should say that this is saying that the 0th term is 1. There's an understood 1 right here. And this one is saying that the second term of our sequence is 16. So let's see here. Is the second term of our sequence 16? Well, no, the second term is 4, so it can't be that one. Is the first term of our, or the 0th term of our sequence 1? No, the first term of our sequence is 1, so it can't be that one. Here, the 0th term, so I need to find the 0th term. So r is 4, so we go back 1. It should be 1/4. So this one would work. We have 1/4, and it's n minus 0, so that one's good. And then this one, 1, 1, the first term of our sequence is 1, so that one is also just fine. Okay, here we go. Next 3. A function of the following coordinate points. Could it be a linear function, exponential, or neither? So first, check our x's. This is +1, so +1, +1, so we're increasing at a constant rate. And this looks like, it's +3 here, and it's +3 here for the y's. So this should be arithmetic, or well, should be a linear function. The first difference is the same. On this one, first check sure, there's +1, check the x's, +1, so constant intervals, great. And then here is +2, oh, that's not good, because this one is +4. So it's not a linear function. What about an exponential? So if I'm multiplying by 12/10, so 5/6, it should be getting bigger. This one's getting smaller. It should be -4, not +4. So it is not a exponential either, so it should be a neither. And then finally, this one right here, our x values are increasing at a constant rate, +1, +1. And this is -6, -3, so it's not linear. This is multiplied by 1/2, and this is multiplied by 1/2, so it must be exponential. So I'm going to write geometric, but fine, exponential. Okay, that concludes page 1. I'll see y'all in episode 2.